Okay, so this is going to start the section 7.3 notes. And you should be able to get this notes packet from the back of the class in the bin that says algebra, so just in case. These next several pages are actually going to be posted on a different page in the book. And so this specific one right here will go on page 15 in your notebook. Page 14 you'll need to get a cover page for section 7.3. But section 7.3 is all about distance and slope. Now for this class we're not going to cover any of the distance formula. We're just going to concentrate on slope for right now. And if you've had pre-algebra or algebra, you might have been exposed to slope, and we'll talk about the slope formula a little bit later on. So let's just get a definition for slope to begin with, and I'm going to kind of zoom in on this part and kind of move this around. But slope is the ratio of vertical change to horizontal change. And this is very important that you go back and think about what a ratio is. Okay, and sorry I had to pause the video for just 1 second. Okay, so a few characteristics that you're going to recognize with slope are several things. And so you'll often hear me refer to slope as rise over run. And remember, when you're doing a ratio, you can set it up as a fraction. And so rise would be the vertical change, run would be the horizontal change. And so just so that you don't forget, vertical is the up and down. Run, in this case, is going to be what's left and right. And we're going to translate this over to our coordinate plane of our x and y axis. So make a few notes for rise, because every year students forget it. If you go up, obviously this is going to refer to the positive direction. If you go down, it is negative. Okay, when you talk about run, that horizontal change, if you move right, and I'm going to kind of run out of room, you're referring to the positive direction. If you move to the left, it's going to be that negative direction. And so we're going to have a combination of these positive and negative values that could affect what our slope is. And I may have to pause every now and then because you may hear baby in the background. So let's do this. I'm going to draw an example, and I'm going to plot these 2 points. -2, 0, and 2, 2. Okay. -2 on the x-axis, and then 0 on the y, and be here. And then I'm going to plot 2, 2, so I'm going to go over 2 and up 2. And I'm going to connect the dots here. Let me get my ruler. We're going to draw this line. Now, what you're going to notice from this section is a lot of graphs are going to already be drawn. Okay, and what we're going to be doing is determining what the slope is if a graph is drawn. So let's talk about this rise and run concept. Okay, so it's rise and run concept. So I'm having to pause and fast forward this several times. So if I wanted to calculate the slope and I didn't know these 2 points, okay, we can use rise over run to kind of calculate and determine what the slope is. And so in this case, I can start at any one of these points. If I start here and I go my rise, I'm going in the +2 direction. I'm going up 2, so it'd be a +2. So rise over run, my rise would be 2. My run would be from this point here over, and that is 1, 2, 3, 4 units. Okay, and so 4 would be over here. Now, one of the things I do want to do, okay, 2 over 4, we can reduce that, so we probably could have chosen some smaller points in between, but my slope would be +1/2. And we'll talk about positive and negative slopes here in a minute, but that's just to give you an example of the rise over run. I could have done the same thing in this direction. If I started at this point, I could have gone down 2 negative and left 4. Okay, so -2 over -4, I still would have gotten a positive 1/2. Okay, and then just to give you a non-example of what slope isn't, okay, we can really only use slope for straight lines. Or what we call linear lines. Okay, and so if I have a coordinate plane, I cannot use slope for graphs that look like this. This is called a parabola. This would be a quadratic, or even something that looks like that. Those would not be examples that I could use slope and calculate slope from. So hopefully this gives you kind of idea of what we're going to be doing with slope. There's going to be several different methods that we use. We're going to go through those in the next several pages. But slope, remember, it's the ratio of the vertical change to horizontal, rise over run. Now, on this next page, okay, finding slope from 2 points, this is going to go in your interactive journal on page 16. It's going to be its own page. Okay. And so you need to memorize this formula. I will not give that to you. And every year I have students flip-flop these. Okay, now finding a slope from 2 points. On this type of example, to use the slope formula, you have to have 2 points. And you can see that this is clearly labeled. Whenever we look at our coordinate pair, the x comes first, then the y, x, and then the y. This subscript here is just labeling that this is the first coordinate pair, this is the second coordinate pair. So if you look down here at your formula, m, okay, is the symbol we use for slope. Okay, so if you see a problem that says m equals a number, then that's telling you what the slope is. Okay, in the formula, this is my vertical change. So the difference between my two y values, y2 will go first minus y1, and then you got to watch your negatives in these. This bottom expression is my horizontal change. Okay, how does my x numbers differ? And yes, x2 minus x1, watch your negatives again. And we'll plug these values in and you can kind of see. Now what I like to do is kind of color code these. So x1, x1. I'm going to use lots of colors on this page. y1, you can kind of see the values when your coordinate pair are going to fit directly in to this formula. x2, x2, you can see that goes on the bottom. And then last but not least, y2, y2. Okay, now remember, borrow that. Now, a couple of things that students miss every year is what happens if you have 0 on the numerator or the denominator. Okay, and so if the 0 is in the numerator, your slope is equal to 0. Okay, and one way to remember that is it's okay if the 0 is in the numerator. Okay, we're going to have 0. O is on the top, 0 is okay. What if 0 is on the denominator? Then your slope is undefined. Okay, and one way to remember that is no. Okay, no would be undefined. So try to use those little tricks to remember, because if you get 0 on the bottom, you can stop the problem. Your slope is undefined. If 0 is on the top, your slope is 0. Okay, so this is the next page. This is slope tree, And this is just to help you kind of remember that when you get a value for slope, you always want to make sure that your graph matches that value, whether it be positive, negative, 0, or undefined. So I'm going to pick 4 different colors. This is going to go on page 17. If you need map pencils, feel free to get map pencils, but this is going to go on its own page. And this is just going to show you the different types of slopes that we have. And so positive slope is going to be anything that looks like this in the positive direction. Okay, positive slope. You can abbreviate, you can write out the whole word, it's up to you. Negative slope. And so if your graph is in that direction, you should have a negative slope. It could be a negative fraction, it could be a negative number, it could be anything like that. If you have a straight line, a horizontal line, this is a slope of 0. And if you remember back on the previous page, this is when you have 0 in the numerator on top. You can have a 0 slope. It's a flat line. Okay, and then last but not least, if you have a straight line, up and down, vertical line, this is when your slope is undefined. Okay, so those are the 4 different types of slopes that we're going to be working through. Okay, so we're moving right along. The next page that we're going to put in our notebook, this is going to go on page 18, and this is finding slope from a graph. Now normally I would have had the graph already drawn, so one thing you're going to have to do is you're going to have to plot a correct graph. Okay, so I want you to plot these 2 points. Plot -5, 0 and -1, 3, and very carefully draw the line through these points. So -5, 0, I'm going to go on the x-axis, count to the left 5 places, draw a dot, and then -1, up 3, those are my 2 dots. Okay, let's go ahead and carefully draw a line so that the middle of the line goes through each of those points. And it's very important that you do this because if we end up using rise over run, we want our graph to easily go through one of the squares where it meets. Okay, now since we know these 2 points, we're going to talk 2 ways you can find the slope from the graph. Okay, the first and easiest one is using rise over run. Easiest thing, especially if you have a clear spot where they meet. And so if I want to do rise over run, and I'm going to start at this bottom point or the top point, it really doesn't matter. Let's do the top point so you can see what happens if we do negative values. If I start at the top point and do my rise, and in this case my rise is going to go down 3 units, this would be -3, and then from that edge here we're going to go to the left 4 places, and so my run, if I'm moving to the left, is a -4. Now -3 divided by -4, negative divided by negative is a positive. My slope is a positive 3/4. Now I want to make sure that if this value is positive, the slope of my graph is also positive, and in this case it is. Okay. The other way you can do is use slope formula. Since we know the slopes, we know the coordinate pairs of these 2, -5, 0 and -1, 3, or we can even pick out a new point where it crosses, that's fine. Most of the graphs may have little dots already on there. We can label this as x1, y1, x2, y2. And then we can plug that straight into our slope formula of y2 minus y1 divided by x2 minus x1. And so this is the easy part. You just take what you've already labeled and plug it straight into the formula. So y2 is 3 minus y1, which is 0, okay, over x2, which is -1, minus x1, which is -5. Now this is what I said earlier about watch your negatives, okay? And so on the top, if we simplify this, 3 minus 0 is 3. On the bottom, -1 minus -5, these two in the middle end up turning positive. And so -1 plus 5 is a +4. And so you can see that both rise over run and the slope formula with these two coordinate points easily give us the same slope. It's in the positive direction. We're good to go. Okay, so we're moving right along in our notebook. Finding slope from an equation. This is another form of the equation that you're going to have to memorize. It's slope-intercept form. This is going to go on page 19 in your notebook. At the end of this video, I will show you what each page should look like. But slope-intercept form you'll need to memorize. It is y equals mx plus b. Okay, this is the general form of an equation. And I want you to highlight your m and your b. Okay, the y and the x are going to pretty much stay there. Now, in this case, remember what we said earlier about slope. Slope is labeled m, so whatever numerical value goes here, this is what your slope is equal to. Okay, your b value will be a numerical value, it could be positive or negative, but this is going to be your y-intercept. Okay, basically this is the easiest way, and is also known as an equation of a line. Now let's give you a couple examples. Okay, if I give you this equation, y equals 2x plus 5. Sorry, I was about to say b. Should be 5. If this was your example, and this is what was given, you want to check, is this in slope-intercept form? Yes. Okay, and so if I ask you to find the slope, you're going to look, and if this is in y equals mx plus b form, then my slope here is going to be m equals 2. That would be my answer. There's no graph I need to draw, there's no points I need to plug into a formula. I can look straight at the slope-intercept formula. What if I don't give you an equation in slope-intercept form? So for example, if I give you something in standard form, okay, 2x plus 3y equals 6. This is in standard form. Remember, standard form is ax plus by equals c. You'll need to know both of those equations. What you need to do first is rearrange standard form to slope-intercept form. Okay, and I'm going to highlight that because it's very, very important. If you're wanting to just look at the formula and determine slope, we can rearrange this to slope-intercept form. So let's do that real quick. Okay, if I have 2x plus 3y, I want to get y by itself. I want to isolate this term, so I need to subtract 2x to both sides of the equation. It's going to cancel here. I'm left with 3y equals negative 2x plus 6. Now, don't make the mistake and just look at your equation here, because slope-intercept form is y by itself. Right now there's a 3 in front. I need to get rid of that coefficient. So divide every term by 3. And so what I get is y equals negative 2 over 3x plus, what's 6 divided by 3? 2. And so this is my slope-intercept form. My slope here is going to be negative 2 over 3. So in this case, I've rearranged this y equals mx plus b. That's where I get my slope from. Okay, but you got to isolate y by itself first. Okay, so last but not least on the single pages. This one's going to go on page 20 of your notebook. Okay, and this will probably be one of the last things we look at. Actually, we'll do page 21 with a couple of examples as well with using the rise over run, but we should have already looked at the example before and been able to determine that. But this is going to go on page 20. This is finding slope from a table. This is going to be probably the harder ones to look at as you go through this. But remember, m, that's my slope. Okay, my change in y, it's the same thing as saying y2 minus y1, x2 minus x1, or rise over run. Now, since we're not using a table, we're going to be looking more at the change in y over the change in x. And so what we're going to do is go from each value, and we want to determine what the change is. Okay, so when I go from -1 to 2, that increases by a value of 3. 2 to 4, it increases by a value of 2. 4 to 5, it increases by a value of 1. 5 to 8, it increases by a value of 3. Now we're not looking for a pattern here, because what we're going to end up doing is comparing the change in y over here and the change in x. Okay, we're going to do the same thing for the y. Okay, -2 to 4 is a difference of +6. Okay, the -2 to 0 and then +4 more. 4 to 8 is a change of 4. 8 to 10 is a change of 2. And 10 to 16 is a change of 6. Now, the hard part here is we're going to calculate the slope for each of these values. Okay, and so I'm going to use 4 different colors to kind of help show which one I'm doing first. So I'm going to look at the change in y, which the change in y of these first two values is a +6. So change in y over change in x. I have a 6 for my y, and then I have a 3, which this will give me when I reduce it down to 2. Okay, so this was the first slope that I calculated. The next slope I'm going to calculate, I'm going to look at the change in y and the change in x for the pink values. Okay, and so m equals, my change in y was 4 over 2, which when I reduce that is 2. Okay. Next one. Okay, I'm going to do the yellow values here. So the change in y, 8 to 10 was a +2. Change in x was a +1, which when I reduce that down, I get a 2. Okay, and then last but not least, let's see if I can find another color. These last two, 10 to 16, okay, was a change in a 6. My x values was a change in 3, and when I reduce that, I get a slope of 2. So you can see that this table of values, landscape slipping, this table of values, no matter what the values are, should be a linear equation because all of the slopes are going to be 2. Okay, and so finding slope from a table, unfortunately this is going to be the longest one. Okay, you find that pattern down here when you actually calculate the slope for it. Okay, so the next 6 pages, and you can see that they're labeled at the bottom, okay, 1, 2, 3, 4, 5, 6, are all going to go on page 21. Okay, they're all going to go on page 21. So example 1, it says graph the line determined by the 2 points and find the slope of the line. So our first job is we want to plot these 2 points, 0, -7, -9, 5. So 0, -7, Okay, my x-axis is 0. I'm going to go down 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, just make sure I counted the right. Okay, plotting -9, 5. -9 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go up 5. 1, 2, 3, 4, 5. Okay, I'm going to very, very carefully plot this to where the line goes through the points. Okay, use that straight edge. Now, the first part of this example, it says using the slope formula. So let's go back up here and label our sets of coordinates. Now, it doesn't matter if you label this one as x1, y1, or this one as x1, y1. I just read the first line. Okay, like I said, I had to pause every now and then, baby crying. Okay, so x1, y1. If I label this as the first pair, I'm going to label this as the second pair. Okay. Now, I'm going to take those points and plug them straight into the formula exactly where I've labeled y2, y1. Now, y2 is 5 minus my y1, which is -7. This is very important that you watch your negatives. This minus in the formula has nothing to do with the minus that's in front of the 7 that I've labeled y1. Okay, so you do need to have both there. x2 is -9 minus x1, which is 0. Now I'm going to simplify these. Okay, what happens to two negatives? So 5 minus a -7 becomes a positive. So 5 plus 7 is 12. Okay. -9 minus 0 is -9. Now, what I have here is 12 divided by -9. Okay, and so I can move that negative sign out in front and see if there's anything that I can do to reduce. 12 and 9 can both be reduced by a factor of 3. So my slope here is -4/3. Okay, now if you're using rise over run, and there's a set of known points, you want to use those points as a reference. Okay, so let's start at this bottom. Okay, if I go up to the point in which my second point is located, that is a factor of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. And since I'm going in the up direction, it's going to be a plus 12. Okay, you don't have to put the plus sign, but just me helping you out. And then from this point over to my point, I'm going left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Left, it's going to be in the -9. Okay, think about that very, very first page that we made. If I go left on a run, I'm referring to a negative number. And then I can do the same thing, pull the negative out in front, reduce 12 and 9 to 4/3. Okay? So two different methods that you have to be able to solve for those. Okay? So you go ahead and do example 2 by yourself. I've already pre-dotted 2 points. So use those 2 points, and I want you to find the slope. Okay, using both the slope formula, make sure you show your work in practice, and then using rise over run. Okay, and I'm going to pause the video. I'd pause it now, do the work, and then I'll show you what the answer is here in a minute. Okay, so hopefully you paused and you were able to work it out. You can see my work here. Using the slope formula, I found the coordinate pairs, labeled them x1, y1, x2, y2, plugged them straight into the formula, and was able to calculate a slope of positive 5/11. And I want to confirm that my slope is going in the positive direction, and as it is. If I use the rise over run, you can either select this point or this point to go from. It doesn't matter. But if I selected from this point, I had up 5 units, and then to the right 11 units for a positive slope. If I started at this point, I would have gone down, which is a -5, and left, which is -11. Negative divided by negative ends up being positive. Okay, so this is going to be page 3, and remember these are all going to go on page 21. Okay, so these are still, we're still continuing on page 21 here. Okay, and it says find the slope of the line through each of the pair points. So if I give you 2 points, the best thing to do is use slope formula. So you're going to be using this formula on every single one of these. Okay, so the easiest thing to do is label these x1, y1, x2, y2, and then plug those straight into the formula. y2 is 1 minus y1 is 1. x2 is 19 minus x1, which is negative 2. You're going to end up showing all of your work. So even if you already noticed this is 1 minus 1 is 0, and what happens when 0 is on top, I want you to go ahead and finish this. Okay, this becomes a positive. 19 plus 2 is 21. When 0 is on top, my slope is 0. So m equals 0 for this first problem. Okay. Number 2. I'm going to label these x1, y1, x2, y2. I'm going to use my slope formula, y2 minus y1 over x2 minus x1, and I'm going to plug those points straight in. So I get negative 8 minus y1, which is 4, x2, which is 19, minus 18, which is x1. Let's simplify this. Negative 8, negative 4, sorry, negative 8 minus 4 is going to be a negative 12. 19 minus 18 is a positive 1, and so in this case my slope is negative 12. Okay, last but not least, C's. I get x1, y1, x2, y2. I'm going to plug it into my slope formula. y2 is negative 8 minus y1, negative 8. Okay, remember you're going to show all work. x2 is negative 1 minus negative 10. Remember, watch your negatives here. So in this case, I have a negative 8 next to a minus, so those end up turning positive. Same thing on the bottom. So negative 8 plus 8 is 0. Negative 1 plus 10 is 9. And so when 0 is on top as a numerator, my slope is 0. Okay? Let's go over to example 4 real quick. Now, there's a few in your homework problem from the book where you're given 2 points, but one of the x values is missing. And then they give you slope. Okay, and so you're going to have to kind of work backwards and find the x term. This is a very, very important one to follow. So here are my 2 points. I get x1, y1, x2, y2. And the problem says find x if the line through 4, 7, and x3 has a slope of 4. So this is my m value. Okay. Now I'm going to use my slope formula. I'm going to plug all of my known values in. Okay, so do I know m? M is 4 over 5 equals y2 is 3 minus y1, which is 7. x2 is x, so I'm going to put that there, minus x1, which is 4. Now, I want to go ahead and simplify if I can. Okay, so this is 4 over 5 equals 3 minus 7 is negative 4. X minus 4 cannot be simplified. And I'm going to have to keep that as one full term on the denominator. Now, this is a fraction equals essentially a fraction. One of the things you can do is cross multiply. And what we're trying to do is get rid of having a denominator. So I'm going to bring the bottom term up, and cross multiply. So what I have now is 4 times x minus 4 by bringing this up, cross multiplying, and then my equal sign, I'm going to bring my 5 up, so negative 4 times 5. Now I no longer have a denominator set. Okay, from here I'm going to solve for my x value. This is just simple manipulation that we learned in chapter 1. I'm going to distribute, okay, and I even don't have to distribute, but most of you that'll be your first instincts. So 4x minus 16 equals negative 20. I'm going to get x by itself by adding 16 to both sides. I get 4x equals negative 20 plus 16, okay, is going to be a negative 4. Divide off 4 to both sides. X is equal to negative 1. And so in this case, my x value from the original problem would have been negative 1. Okay, now using the graph to solve. Okay, so if you wanted to do this using a graph, you could do the same thing. You do know one of the known points is 4, 7. So let's go ahead and plot that. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, now unfortunately you don't know the second point. However, you do know the slope. Okay, now if we wanted to do positive 4 and positive 5, we would be up on the graph. But we know that this is going to be a positive slope. So if m equals 4 over 5, that's the same thing as saying negative 4 over negative 5. So I can use that and do rise over run. Let's go in the negative direction. 1, 2, 3, 4, and then left 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. I want to get enough points, and then I can draw my line. Now this is very important. Do any of these points have a y value of 3? So let's think about this right here was 4, 7. Okay, this one right here, if we were to calculate that point on the graph, it would be negative 1, positive 3. This one right here would be 1, 2, 3, 4, 5, 6, negative 6, negative 1. And so if we look at our original problem, x, comma 3, well, when y is 3, my x is negative 1. So I can do this as another method. Even though this takes a little bit longer, algebraically would be the easiest one to solve. But if you have a graph, you can also solve it that way. Okay, so the last 2 pages, remember these are still going to go on page 21, so you'll make that little booklet and stack them on top of each other. Example 5 is just like the last one we did, except we're going to be solving for a y value here. And so I get 2 points. One of those has a variable instead of a numerical number, and then I have a slope of and a value. So I'm going to go ahead and label these x1, y1, x2, y2, and this is my m. I'm going to use my slope formula. M equals y2 minus y1, x2 minus x1, and then plug in those values. So m is 3 over 2 equals y2, which is y, minus y1, which is 3, x2, which is 2, minus x1, which is 6. And I want to simplify anything that I can. So this is going to be 3 over 2 equals y minus 3. 2 minus 6, okay, is going to be a negative 4. Now from here, I need to keep y minus 3 as a term, and I'm going to cross multiply. I'm going to bring the bottom denominators up. I get negative 4 times 3 equals 2 times y minus 3. And now I no longer have a denominator. Okay. From here, I'm going to move this up top. Negative 4 times 3 is negative 12 equals, and I'm going to go ahead and distribute because I know that's the first thing you guys will do, negative 6, which is fine. Let's get y by itself, so we're going to add 6 to both sides. Okay, negative 12 plus 6 is a negative 6 equals 2y. Divide 2 off. Okay, and I'm going to switch my y to either side. Negative 6 divided by 2 is negative 3. And so in this case, y is negative 3. Remember, once again, you can graph this if you want. Okay, we know the point 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. We know a slope of 3 over 2. Okay, I can go in the positive direction or the negative direction, it's fine. 1, 2, 3, 1, 2. Or I can go down 3 and left 2. And I want to do several points because what I'm essentially looking for is enough points to draw a really good line. Okay, and so if my x is equal to 2, where does that cross? Down here. So this is 2, negative 3, which it does confirm my point. Okay, last page. If you need to pause, rewind any of these, it's fine. Okay, so example 6, super easy because all of these are in slope-intercept form, and if I'm trying to find the slope of the line, if it's in y equals mx plus b, my slope is going to be the value in front of m. Now make sure your y is by itself, in which all of these are. And so y equals mx plus b, my slope here is 7. Okay. On b, my slope here is 2. And then on c, my slope is going to be the negative 6 over 5. Those are super easy if the formula is in slope-intercept form. Now on example 7, we do not have slope-intercept form, and so we're going to have to do some rearranging. Okay, I'm going to have to zoom in real quick. So I want to get y by itself. So first thing, subtract 9x to both sides. I'm left with negative 2y equals negative 9x plus 10. To get y by itself, I want to divide off negative 2. And so y equals, now negative 9 over negative 2 becomes positive 9 over 2x. That cannot be reduced. Okay, 10 divided by negative 2 gives me a negative 5. Okay, or you could put plus minus 5 is fine, plus negative 5. But once I get my equation into slope-intercept form, my slope is going to be a positive 9 over 2. Okay, let's do b real quick. X is equal to 3. Now think of this. Okay, remember Hoy and Bucks. This is going to be a vertical line. Okay, and if I have a vertical line, which is up and down, my slope is undefined. Okay, and so my answer would be undefined, or you can even put m equals undefined. Okay. C, get y by itself. First things first, I need to subtract 4x to both sides. Now this negative is attached to the y, so don't drop it. I get negative y equals negative 4x plus 1. We divide off negative 1, or we can distribute the negative. Basically everything that's negative now turns positive. Everything positive now turns negative. And my slope here is going to be m equals 4. Okay. Last one, get y by itself. Subtract x to both sides. Y equals negative x plus 1. This is in the format of y equals mx plus b. Okay, this value here is an understood 1. So m is equal to negative 1. You don't see the 1, but it's an understood. Okay, and so this is what you should be able to get through by the end of this first lesson. I'm going to show you the book, Interactive Journal. and what goes on each page. Okay, and so in your journal, zoom out just a little bit. We last left off on page 13. That was section 7.2. So on page, you can pause, 14, you'll need to get a cover page from the back. Okay, this will be for section 7.3. I don't have one here at home, but you can do it on your own. Okay, page 15, this is where I did the first one. I titled it, What is Slope? Glued that page down. Page 16 is the finding slope from 2 points. I labeled it slope formula. Remember, you can pause at any time in this video. Page 17 is slope tree. Page 18, finding slope from a graph. Okay, and this will help you with the homework set number 1. Okay, slope from the slope-intercept form on page 19. This will also help you with homework set number 1. Page 20, slope from a table, also from homework set number 1. Page 21, this is where I'm going to label those 6 pages. I stacked them all next to each other, stapled them down. This will help you with numbers 17 through 32 in your book. Page 22, we have not gotten the notes yet. That'll be the next class, okay? So if you can get up to page 21 glued down in your interactive journals before Wednesday, you're good to go.